So they're telling us to write a transformed exponential function that has the parent function of y equals 2 to the x. So I know typically 2 to the x has a y horizontal asymptote of the x-axis. And what I'm seeing is, well, I know that it's been reflected. I also know that around the x-axis, I also see that it's been shifted up. Because if it was just reflected around the x-axis, it would look something like this red line. Okay, so I see it's been shifted up to this up one. So what I'm going to think about this is I'm going to add 1 to that. Okay, so far so good. So I ought to see if it's been stretched at all, because it could have been shifted left or right. It could have been stretched. So what we're going to do, but one thing I'm noticing that it has a 0 when x equals -2. So when x is -2, y is 0. I'm also seeing a y-intercept of -3. So we should try both of those points in this function and see how we have to transform it at all. So I know that -3 equals 2 raised to the 0 plus 1. Well, is that true? Well, that's going to be 1 plus 1 is 2. Well, that's not equal to -3. That tells me that there's some stretch factor, some coefficient here. And so what I need to do is solve for that coefficient. So I'm going to subtract 1 from both sides, of course. And that's going to show me, that shows me that a equals -4. So I'm guessing I've got a y equal -4 times 2 to the x plus 1. Now I've got this other point that I haven't used, this -2, 0. Let's see how that works. Does this equal to 0 if x is -2? Let's see, so what's that? That's 2 to the -2 plus 1. So what I have is -4 times 2 to the -2 plus 1. Well, 2 to the -2 is the same as 1 over 2 squared, which is 1/4. -4 times 1/4 is -1, plus 1 is indeed 0. So it looks like I've got a function right here that works for this expression. And all I did was start substituting in points. So I'm seeing another transformed function. It looks to me like this is almost like an exponential decay function that's been reflected around the x-axis and then shifted up 3. So I'm thinking I've got this at this point. And then I want to check and see if I get this y-intercept of 1. I've got to substitute in 1 and x here, or 1 and 0 here, and see if I do get 1. So 1 equals 2 to the 0 plus 3. Well, let's see. That's going to give me 1 plus 3 is 4, not 1. So there must be some factor that's out, some initial term here out in front. So if I subtract 3 from both sides, I get a equals -2. So at this point, I've got y equals -2 times 2 to the x plus 3. I could do some shortcuts, but I see this point here, 1, 2. So let's see what x has to be, or maybe there's some, maybe it's a reflection. Well, in fact, I know it's a reflection. I know it becomes exponential decay. So let's see, 2 equals -2 times 2 to the, I'm going to call it a times 1, because I don't know what that number is, plus 3. So let's see, I'm going to subtract 3. I'm going to divide by -2. So that tells me 2 raised to some power, or 1 times a, has to equal 1/2. Well, if a equals -1, that makes it 2 over -1. So I'm thinking if we just insert a negative in front of here, that'll give us that function. Oh, I need a -2 out in front, don't I? So I went out to Desmo and graphed the equation I just got, and so what am I noticing? I'm seeing it does have a y-intercept of 0, 1. I also see when x equals 0, y equals 2, which checks there. Now if I check this other point, I'm seeing when x equals -2, y equals -5. When x equals -2, it's off the graph, so I can't really see it, but it's approximately. On the Desmo graph, you could see it. Okay, so I think I'm right. I think that's the function. So for this function, they aren't telling us the base. I found some points. I found the y-intercept is 0, 5. I know it goes through the point 1, 1. So and then I'm also noticing that it's been reflected and shifted up 7, because it's not around the y-axis. Not the y-intercept normally is around in the x-axis, right? So now it's up here at y equals 7. So I know that the plus c is going to be 7. So plus 7. And I don't know what a is yet. I do know that if I raise b to the 0 power, though, that this whole thing is equal to 5. So that would tell me that a equals -2, because b to the 0 is 1. Then I'm going to subtract 7. So I'm thinking I've got y equals -2 times something to a power plus 7. Now I've got this other point, 1, 1, that I can use. And if I solve that for b, that's going to give me what? Let's see, -6. And then divide by b, or divide by -2, that gives me b equals 3. So right now I'm thinking y equals -2 times 3 to the x plus 7. And now I'm going to try graphing that and see what it looks like. So what I'm seeing is I'm seeing the y-intercept of 0, 5. I'm also seeing it crosses the point 1, 1. I think we're good. I think that's the function. So for this function, I'm finding these 2 points. I'm also seeing the horizontal asymptote is down at -4, and I know it's going to be a decay function. So the exponent could be negative. Could write the base as a fraction. So I know at this point I've got y equals a times b to the x minus 4, and I know when x equals, here's another point I didn't use and we should use it. When x is 0, y is -2. So -2 equals a times 1, because b to the 0 is 1, minus 4. So that tells me that leading coefficient is, let's see, add 4, that gives me 2. So y equals 2 times b to the x minus 4. Then I've got a couple of points I can use. I don't know. How about I use the -1, 0? So 0 equals 2 times b to the -1 minus 4. So that gives me 4 equals 2 over b, because b to the 1. And if we do my cross products, so b equals 1/2. So it's looking like this function is y equals -2 or +2 times 1/2 to the x power minus 4. I mean, I could do this a couple ways. I haven't used this 1, -3 point. Let's see, is -3 equal to 2 times 1/2 minus 4? Was 1/2 to the 1, right? So -2 times 1/2 is -1. positive 1. Minus 4 is negative 3, and that does check. So that looks like that's the right function.